Okay, so we are going to go ahead and move on to a new unit, and we're starting this new video thing. It is a trial and error type of deal, so bear with me, especially if I kind of mess up with my controls here. So this unit, we're going to get into some right triangles and using trigonometry, so sine, cosine, all that stuff I'm sure you probably heard of but aren't too familiar with. So we're starting out with looking at the Pythagorean theorem and its converse. Now we looked at the Pythagorean theorem kind of, I think it was like in the first chapter, I believe, and we kind of just talked about it briefly. We didn't go over a whole lot about it. So I'm going to try and make these videos brief. Feel free to pause at any time if you need to catch up, anything like that. That's the point of these, is I can move quicker and you can take your time. You can go as fast or as slow as you want, okay? So on the first page of your notes. So I'm going to zoom in here. Remember, when we're looking at a triangle, we use the Pythagorean theorem to find the missing sides, or the missing side, single side, sorry, of a right triangle. We can only use the Pythagorean theorem on right triangles, okay? So remember, sides A and B, so this one right here and this one here, those are what we call the legs, if you remember that, okay? Then side C is called the hypotenuse, which should sound familiar. I forgot how to spell hypotenuse. There we go. Okay, so for any right triangle, remember a squared plus b squared equals, equals c squared. Okay, and that's our Pythagorean theorem. All right, so let's try and look at a couple examples of this. So we want to find the value of x and round our answers to the nearest tenth. All right, so looking at number one, I'm given both legs. So it doesn't matter which one's A or which one's B, but all you do is plug these values into the Pythagorean theorem and solve for C. C is always the hypotenuse. Okay, so that means we're going to take 8 squared plus 13 squared, and that's going to equal c squared. All right, so 8 squared gives me 64 plus 169 is 13 squared. That's going to equal c squared. All right, so now all I do is keep solving. 64 plus 169 is going to give me 233, which is equal to c squared. You can use x as well, because we're solving for x technically. I plugged in c. Either way will do. So then remember how to undo c squared is to take the square root of both sides. So then that leaves c equal to 15.3. Okay, and I'm actually going to go ahead and write that in here so that we're clear, because we're trying to find x. X equal to 15.3. And that's our hypotenuse. Okay, so sometimes we're not always given just the legs. So for instance, if you look at number 3, I'm going to skip number 2. If you look at number 3, in this case, we're given one of the legs, I'm going to call this one A, and the hypotenuse. And it's our goal to find the other leg. So again, all we do is plug in and solve. 7 squared, my pen is trying to freak out, 7 squared plus, and I'm going to go ahead and use x this time, plus x squared equals 9 squared. So I go ahead and continue solving. 49 plus x squared equals 81. And then that means x squared equals 32. And then I take the square root of both of those, and I end up with x equals 5.7. Again, remember, we're rounding to the nearest tenth. So that means this leg, B, is 5.7. All right. So we can also use the Pythagorean theorem when we're looking at different types of triangles. Think about what kind of triangle the one on number 5 is here. Notice when I have the 2 tick marks there, that tells me those 2 sides are congruent, which means that those sides, that this is an isosceles triangle. So that means this side is also 24. All right. So when I have this isosceles triangle and I have this line going down the middle here, what that does is it cuts this bottom side directly in half, making these congruent. When I cut 22 in half, that makes both of these sides, my tick marks actually make an 11. Now I've formed 2 right triangles here. Now I can use my Pythagorean theorem and solve for x. So I can take, let's see here, 11 squared plus x squared equal to 24 squared. Okay? So 121 plus x squared equals 576. X squared then equals 455. So then that leaves x equal to 21.3. Okay, so we can use it to find different parts of different kinds of triangles. I mean, if you look at the shape on number 6, it's even more different. So I'm going to skip that one for now, and I want to look at number 7 now. So this one's kind of different. We're now trying to find the whole length of the bottom part of this triangle here. Let me switch colors. So, trying to find the whole length of this bottom part here. But notice how I have this line here that comes down and forms a right angle. Do you remember what this kind of line is called? It's an altitude. So we have this altitude drawn in here for us that comes down and forms a right angle, meaning that I have 2 different right triangles here. This one here and this one here. Okay. I can use that to find each of these 2 little pieces. I'm going to call them A and B. Okay. Once I find both A and B, I can then put them together to find x. So if I'm trying to find A, I would have 12 squared plus A squared equals 14 squared, which gives me 144 plus A squared equals 196. A squared equals 52. And then A equaling 7.2. So that's this little piece right here. Then I have to find this other side here that I called B. So again, do the same exact thing. And you can shorten it if you'd like, kind of rearrange the equation. If you have one of the legs and the hypotenuse, you can already tell that you're going to have c squared minus, I'll call it a squared, equals b squared. And you can substitute that in, that way to save yourself some time if you would like. I choose not to, just so I don't confuse myself. So again, I have 12 squared plus b squared equals 29. 29 squared. So 144 b squared equals 841. So then b squared equals 697, leaving b equal to 26.4. Now, just to find x, all I do is combine those together. X equals 7.2 plus 26.4, which gives me 33.6. Okay, so I'm breaking this triangle into pieces, and I'm using those individual pieces to find my missing sides, to find that missing information. So when you're doing like number 6 and on the back of the first page, number 8 and number 9, think about what shapes you're making out of those, or what new shapes you're making when you break that whole shape into different pieces. Okay, so you can go ahead and pause now and do 2, 4, 6, 8, and 9 if you want, or you can keep going and come back to them at the end. That's up to you. Because I want to go ahead and move on to this application section on the back of the first page. Okay. So what this is wanting us to do is draw a picture for the situation, which is very important. I want to see pictures drawn. And then solve for the missing side. And again, we're rounding our answer to the nearest tenth. All right. So, number 10. A roofer leaned a 16-foot ladder against a house. All right, so that's going to tell me what I need to draw. So, I need to have a house. Remember, I'm not an artist. I'm a math teacher. All right, here's my house. And I have my roofer that leaned, wow, epic fail. Leaned the ladder. Looks more like a slip and slide, or like a water slide. But it's a ladder. A ladder against the side of a house. So the ladder is 16 feet. Okay. If the base of the ladder is 5 feet from the house, so I'm going to zoom in a little bit more so I can draw it. This is 5 feet. It's 5 feet from the house. How high up does the ladder reach? So what we're trying to find here is, and I'll put it in maybe brighter red here, we're trying to find the length from the floor, or from the ground, I'm sorry, to where the ladder stops. Okay? So again, we just use our Pythagorean theorem. So I would have 5 squared plus x squared equals 16 squared. All right. So then 25 plus x squared equals 256. So then x squared equals 231, leaving x equal to 15.2. Okay. So how high up does the house, or high up the house does the ladder reach? 15.2 feet. Okay? So, again, this is why I stressed to you that pictures are important. I want you to draw a picture. Okay? If I check your notes and I don't see pictures drawn, I'm going to be upset. Okay? It's going to help you see what you're trying to find just a little bit easier. Okay, so again, take a second if you want to pause and do 11, 12, and 13. Feel free. If not, we'll keep going and come back and do them at the end. All right. So go ahead and flip to the last page. We're going to talk about the Pythagorean theorem, converse, and how we use that to classify triangles. So if I'm given a triangle with sides A, B, and C, if different color here. If C squared equals A squared plus B squared, then the triangle is right. Right? That's our Pythagorean theorem. Okay. Now, if C squared is greater than A squared plus B squared, then the triangle is obtuse. Okay. If C squared is less than A squared plus B squared, then the triangle is acute. Okay, so I'm not quite sure why it says that, but it wants us to always keep C squared on the left side to avoid confusion when classifying. So I would suggest that you do that. Now, before we start solving these next few, it says first determine if the three sides could form a triangle. Now it says recall from earlier, but I don't remember if we ever mentioned that in this class. But the sum of the two smaller sides of a triangle must be greater than the third side. In order for it to be a triangle. So if the sum of the two smaller sides is less than the third side you're given, it's not a triangle. Okay? And so I'll kind of talk about that. We'll do an example of that here in a second. So then if it is a triangle, we need to classify it as acute, right, or obtuse. All right, so let's look at number one. So first we have to determine if the three side lengths could form a triangle. So that means we have to take the two smaller sides, 3 and 7, add them together, and make sure that it's greater than 9. So 10 is greater than 9. So yes, it's a triangle. Okay? All right, so now we determine what kind of triangle it is. Okay? So that means we're going to take our largest side, which is going to be 9. That's going to be our C. So 9 squared. And then I'm going to use just a little dashed line here. And we need to find out if it's equal to, greater than, or less than A squared plus B squared. So 3 squared plus 7 squared. So 81 and 9 plus 49. So that's when we look at, is 81 greater than, equal to, or less than 58? Well, it is greater than. So when we look back up here, that means it is an obtuse triangle. Okay, so we're going to mark obtuse. And that is that. Okay. So we use the three side lengths of a triangle in order to classify it. We did a whole section unit thing on classifying triangles. This is just another way we can do that. So let's look at We'll go ahead and look at we'll look at number 3. All right, so again, I got to first determine, is it a triangle? So I got to take my two shorter sides, 4 and 11, 4 plus 11, and I got to see if that is greater than 16. So 4 plus 11 is 15, which is not greater than 16. So it is not a triangle. So these side lengths cannot possibly form a triangle because the two smaller sides do not add up to be greater than the longest side. Okay. So that is what you'll be doing on 2, 4, 5, 6, 7, and 8. You're going to go through, you're going to see, is it a triangle, for one thing? If it is, then you're going to classify it. You're going to use these rules up top here, the Pythagorean Theorem, Converse. You're going to use that to classify what kind of triangle it is, whether it's acute, right, obtuse. Well, yeah, that's it. Acute, right, or obtuse. Okay. So that is all I have so far. I want you to, if you haven't gone through and done the ones we did not do together, I want you to go ahead and go do those. If you get to one where you're stuck, do the best you can, and then just, I don't know, put a star beside it, or circle it, or put a square around it, something like that that tells me that you need us to go through that one together as a class, or you have that one you need to ask me about in class. All right, so that is all I have for Pythagorean theorem and its converse.